What's up everybody, my name is Smoke with Smoke Arts and Moonwraith Studios. Today we're going to be starting another series where we're learning together, and we're going to be doing Codecademy's Introduction to Game Development together. Let's jump right in. Codecademy's Introduction to Game Development. Get started with game development. So what is game development? Video game creation has come a long way since the days of 8-bit games created by small teams or even a single person. Many modern video games have teams of people working on them year-round. These games are expected to immerse us in their stories and gameplay using audio visuals equal to the quality of major motion pictures. Even games created by a small team or a single person can reach a quality that wasn't even feasible not so long ago. Sorry about that. In this course, you will be taken through the process of video game development, from design and gameplay to art and sound assets, and finally, the tools of the trade. The content in this course requires no previous knowledge, and anyone interested in the topic should feel comfortable exploring this course at their desired pace. The goals of this course. By completing this course, you should be able to achieve the following. Understand video game design process, from generating an idea to choosing the proper hardware. Understand the concepts behind gameplay development, such as game mechanics, artificial intelligence, and practical user experiences. Understanding the design and creation of video game art and sound assets. Understand the programming languages and tools used during video game production. Alright, here we go. Introduction. Every game begins with an idea, and this idea can come from anything. It can come from a personal experience you had and think, hey, this could be a fun game to play. It can come from an already existing game that you had your own fun little twist to. In this lesson, we will explore how to bring your game idea to life, including following topics: game types, user experience, objective design, game parameters, game aesthetics, game platform, and game controls. The chess grandmaster Robert Bobby Fischer felt that players were over-preparing for games of chess by memorizing a series of moves from the starting position. The classic chess board setup is shown here. To prevent this, Bobby Fischer proposed a variant which is shown above. Chess 960, where the pieces were randomized, forces a player to think on their feet. This is an example of a new game derived from a classic one. By the end of this lesson, you should be well equipped to turn your idea into a game design. For this lesson, and others in this course, we will play with the following platformer game that has Cody dodging or destroying bugs while searching for the goal, a golden portal. Feel free to play a few games before moving on. Alright, cool. So they gave us a little game to play. So, move left. Yeah, so it's WASD. Jump is actually W. Oh, and I lost. And, space also shoots, but it also makes my bar go down. Weird. Okay, I wonder if I can go. Oh yeah, I can actually go. Cool. So this is, I guess this is probably what we're gonna learn how to make here. Either that or like this is just an illustration. But yeah. Game type. Before we define rules or start sketching out game art, we must first consider what type of game we're trying to make. Once we determine what game type we want to make, we can start working on its other aspects. We cover these in later exercises of this lesson. The following is a list of some of the most common game types. A platformer. A player controls a character that has to run and jump on platforms while avoiding obstacles. Multiplayer online battle arena, or a MOBA. Multiple players face off in an arena-style environment. Sports. A representation or a current made-up sport. A representation of a current or made-up sport. So like FIFA or Rocket League. Role-playing game, RPG. Players assume different kinds of fictional characters and play through a story. Puzzles and strategy. Puzzles are solving problems and puzzles through specific challenges, and strategy is slower, sometimes turn-based gameplay that requires different strategies to win. And action-adventure, a high-paced game with the character going through a series of quests or missions. These are some common game types, but over the years, many types have evolved to make new, exciting game types. When designing a game, selecting the game type can depend on your initial idea or preferences. For example, Do you want to create a game where the character has to solve missions to win? This might be an action-adventure game. Do you want to make a game where players can control characters that face off in an arena? You might design a MOBA. Do you want to create a fictional world where players can assume different fictional roles? You might make an RPG. We must clearly define these things at the beginning of the design process. Alright, and we already went through the cards, so we're going to go to the next slide. So you want to think about these things here. And it's going to auto-scroll, but I'm going to stop. So we'll go through these after I read the left side card. Player experience. One of the most important things to consider in game design is the player's experience while playing our game. Generally, we want to design a game that someone will enjoy playing. To create a fun game, we will have to consider the following things: human emotions, the challenge a game presents, and a player's game preferences. Oh, so it actually goes through these. So yeah, we'll just read the left card. Emotion. One of the critical elements of the human condition is that we must consider emotion. Think about the time you played a game and won. Did that not feel good? Did it make you want to play again? What about when you lost? Did you want to go back and try again? When creating a game, we must remember what emotions we want our players to experience. Challenge. A game is considered enjoyable if it is the right amount of challenging, and it shouldn't be so easy that it'll be boring, and it shouldn't be so complex that it feels hopeless to win. This is accomplished by presenting the player with a problem to solve. Once a player passes this challenge, they'll feel good. The harder the challenge, the more satisfying solving it will be. But if the challenge is too hard, the player will likely quit in frustration. Finding the perfect balance will require some trial and error. Player preference. What we, as the game creators, may find awesome might not come across the same way to our intended player. Consider their age, culture, and a player's preferences when designing a game. Popular games are considered addicting because they do an excellent job of balancing the player experience. Angry Birds and Flappy Bird are two very addictive mobile games. They achieve this by balancing out the player's emotional response, the game challenge, and player preference. We should keep these in mind when designing a game. Game objectives. Once we have decided on the game type and what experience we want, it's time to consider the objective. Every game has an end goal or something the player needs to accomplish. Without this, there wouldn't be much interest in playing our game. When considering what objective to design, we must be consistent with the player experience we wish to create. We want to design an objective that will make someone happy when they achieve a goal or beat our game. Some common goals and sub-goals include completing a puzzle in the lowest amount of time possible, beating a boss to advance to the next level, finding some hidden key or treasure that will unlock more powers or accessories, completing a side mission, or score the most points in a game. Along with the primary objective, a game can also have some sub-objectives. During gameplay, the player must complete these sub-missions or side quests. They're crucial because they keep the player engaged and add extra content. An optional sub-objective will offer an interested player more things to do in our game and allow a casual player to complete the game more quickly. Carefully crafting sub-objectives will make the game more fun for the player. In Pokemon Sword and Shield, the overall objective is to defeat different gym leaders to become the Pokemon League champion. The sub-objectives throughout the series and most Pokemon games are to collect the Pokemon. To beat the gym leaders, you have to use your collected Pokemon to fight the gym leaders. The above screenshot highlights the optional sub-objective of battling the Pokemon Landorus. While, I don't know if I said that wrong, Pokemon fans don't come for me, while collecting powerful Pokemon like this one is a sub-objective, it'll help the player with their primary objective of defeating the gym leaders and obtaining the title of Pokemon League champion. Remember to keep the objective consistent with the player experience in the game's theme. I think that is awesome advice. Let's go back to Cody's adventure. When playing the game, what's the objective? Is there only one main objective? What are the sub-objectives? Are there sub-objectives that aren't necessary for the game's success but increase the game playing experience? Let's see. Sorry, I'm not used to the WASD anymore. I playtest so much on RPG Maker that I forget how to use WASD controls sometimes. I don't know. Is there a... Oh, you can stomp on him like Mario. Okay, cool. Oh, I won. Okay, so no, there are no sub-objectives. Oh, no, there is. Okay, so, I would say this is your main objective, which is to get it done in the time. And this is your, uh, wait, did I say sub? Main objective is to beat it in the time, sub-objective is to, like, kill the bugs. So, yeah. Or I guess it depends on their design philosophy, but could be backwards. Game mechanics. Game mechanics are how the player controls the game and consist of rules regarding the movement of player characters, environment, allowances, and the general rules of a game. Game mechanics also includes how a game reacts to player controls, which will follow a set of rules. These mechanics include the space of a game, the setting of it, the state of the game. This could include player score or health, current level, or other important game variables. Actions. These are the options available to our player that can affect the game state, such as character movement. Necessary skills. The skill set the player must have in order to complete the game successfully. Elements of chance. Randomness added to the game, such as random enemy actions or something like a dice roll. To illustrate the concept of game mechanics, let's take the above example of Super Mario Bros. The screenshot shows Mario jumping to retrieve a mushroom that'll make him big. This state mechanic of becoming big is crucial because it allows Mario to be hit twice before losing a life. Other mechanics in this game include space, a fast-paced side-scroller with platforms, enemies, and power-ups. State, displayed on the top of the screen, including the character Mario, a score of 32,950, 17 coins, level 4, 1, and 376 seconds left to complete the level. Actions are walk, run, jump, and duck. Skills are a combination of the above actions to help complete the levels quicker, collect more coins, and get more points. Randomness. Enemies may follow patterns, but can move in unpredictable ways, such as the Lakitu in the Smiling Cloud, who throws the spiked shell enemies at Mario throughout this level. It is imperative that we keep the reward and the penalty parameters consistent with the desired player experience for our game. Remember to make a player feel good when they do something well and inspire them to do better when they perform poorly. Now it's time to look at some game mechanics in Cody's adventure. The game is now attached to a few controls that will change the aspects of the game's mechanics. The show timer can be used to toggle the countdown clock. This affects the state of the game. The Cody binary blast checkbox controls whether Cody can shoot ones and zeros at the bugs. This affects the actions of the game. The Cody move speed slider affects how fast Cody moves and affects both the actions and the skills of the game. So play around with the controls and see what the mechanics of the game make it harder or easier. Alright, so it's I don't think it's working. I think it's broken. I think it's broken. Yeah, it's if I go to okay, well, it's not working, so we're gonna just keep going. You guys don't really need to see that anyway, so it doesn't really matter. I didn't realize that it was the majority of the reading was gonna be on the left, so I'm actually gonna move my avatar to the right real quick. Alright, there we go. Now you guys can actually read along with me, see the examples, and I'm really only covering the next button, so you don't have to worry about that. Game design, which is one of my favorite parts of the process. Game story. Depending on the type of game we are designing, we may have to create a storyline. Storylines can help with the player's emotions by giving them something to connect to while playing the game. Not all games have a storyline, however. The popular mobile game Flappy Bird has no storyline. The only goal is to maneuver a bird through a series of disconnected pipes without colliding with them. A game's storyline should be designed around the game's objective and sub-objectives. Having the story progress while the player completes sub-objectives can motivate the player to keep going. The storyline would ultimately lead to the end objective, which is what the player has been working toward throughout the game. Let's revisit the Pokemon example from the game objectives exercise. The storyline is worked around the game's objectives and sub-objectives. While collecting Pokemon is generally enough to get people to play the game, the story allowed players to connect to the game as they played, allowing them to feel emotions by defeating a trainer or finding a hard-to-find Pokemon. Remember to keep the storyline consistent with the desired player experience. So, this is Final Fantasy XV, I know because it's like the only one I've played all the way through and multiple times, but Prince Noctis and his friends must reclaim his kingdom that has been invaded by Niflheim. He must defeat the evil powers using the powers of the Lucian kings. This is Assassin's Creed, the original, a struggle between the Assassins and the Templars. Assassins fight for peace and free will, and Templars fight for peace through order and control. We've got Batman, I'm not sure which one, Arkham City. Batman must free himself from the Arkham City prison by uncovering the scheme of the prison's warden, Hugo Strange. I think I played that one, actually, and this I'm not familiar. StarCraft. Human Terrans, psionic Protoss, and insectoid Zergs fight for dominance in a remote region of the galaxy. Never played that, so interesting for me to learn that. Game platform. In this exercise, we explore the concept of the game platform, which is the physical hardware in which our player will play the game. When designing a video game, we must decide on what platforms our game will be played on. Each platform has its advantages and disadvantages, as well as a few options for game controls. Personal computer, or PC. Computers can include up-to-date hardware to play some of the most resource-intensive games. An entire industry is based on making different computer configurations for video game play, but not all people's computers can play games. Older hardware configurations will not be able to handle some games. Console. If we design a game for console, such as Nintendo, PlayStation, or Xbox, our game has access to very powerful hardware, but to make your game available to multiple consoles, you must use their developer tools, defined by each console. This can be a lot of work, especially for independent game designers. Mobile. We can reach more people if we design our game to run on a phone. Most people have phones, and they can play our game while they're on the go or when they're at home. But a phone's hardware is not as powerful as a computer or a game console, and this can limit our ability to provide a rich experience. When it comes to video games, we must consider what technology we will use to create the game. Each platform has its pros and cons to help guide our decisions. Yeah, we'll go through those so you guys can get the full experience of it. I'll read through these little modules here if I feel like it gives you relevant info. Otherwise, we're just gonna go through it because I don't want to make this video 3 hours long. But for computers, your pros are common and readily available, can be relatively cheap, and hardware can be replaced and upgraded. Cons. High quality hardware is expensive, high level games require expensive hardware, and they cannot be used on the go. Which you could consider laptops, but we're just gonna take it at face value. Consoles. The pros are they're specifically designed for gaming, they have higher quality hardware for a lower price, and they comfortably support multiplayer gaming. Cons are that a screen or monitor comes separately, not all consoles are available in every region, and they cannot be used on the go. That is also... There's like PSP, Nintendo Switch, and all that stuff, but like I said, face value. Platform for mobile. The pros are that it's small and versatile, games can be played anywhere, on the go, very common and readily available, but the cons are that the hardware isn't optimized for gaming, can't support advanced games, and multiplayer games are less common. Game controls. Once we have decided what platform we are using, we must decide how our players will interact with the game. Game controls are the input of our video game. Our job is to determine the most appropriate control to deliver the intended experience. Most common types of inputs for a video game are as follows: game controller, aka the gamepad or joystick, the keyboard and mouse, touchscreen, real-world interface such as a steering wheel, and many others. The game controller is the most widely used input as it is the primary controller for all consoles and can be used with a computer and a phone. This is an advantage because it's usually intuitive and relatively inexpensive. When designing a game for console, this will likely be the input control of choice. Keyboard and mouse. A keyboard and mouse are the most commonly used input controls for PC games as they're readily available. Many gamers opt to use mice and keyboards designed explicitly for gaming. These can provide many options for gaming that standard keyboards and mice cannot. One disadvantage of a gaming keyboard and mouse is that the cost can be a lot more than the standard options. Touchscreen. The touchscreen is the input control of choice for a mobile game, as this is the standard way to interact with a phone or tablet. The touchscreen has created many new types of games where finger presses and swipes are the preferred method of control. When it comes to playing classic games requiring game controllers, the touchscreen can sometimes be more challenging and not the best choice. Real-world interface. Sometimes a game can be intended to give a more real-world feel. Therefore, some custom controllers can be specifically designed for certain games. For a flight simulator game, a player can purchase a setup that mimics a fully functioning flight deck, complete with all the controls that can be found in a real airplane. This can increase the player experience, since it will seem like they're flying a real aircraft. However, this control setup can be pretty expensive. As technology advances and so do game controllers, with virtual reality and augmented reality becoming more common, games designed in these realms that games designed in these realms will have new and innovative types of controls. So we're going to go through these, I guess. Let's see. We already read through all this in this part, so. All right, review. Congratulations on finishing this lesson. I cannot. My goodness. Sorry, I've been developing all day, so I'm rather tired and it's like 9 p.m. Congratulations on finishing this lesson on game design. You are now equipped with everything you need to design an awesome game. Let's briefly recap everything we learned. When designing a game, you must first consider what type of game you're trying to make. Always keep in mind the experience you want the player to have, as this is the central focus of the design process. The objectives and sub-objectives of your game define the goals of the game. The mechanics of the game define the relevant parameters of the game. If your game has a story, it should illustrate the game objectives and sub-objectives. Consider what platform you want your game to be played on, and consider how your game will be played on the platform of your choosing, aka how your game will be controlled. This screenshot is from the very popular game Untitled Goose Game. The premise is simple. You are a goose and you must complete tasks while avoiding most people to move through the game's stages. That's a tongue twister. Did the developer tell themselves they wanted to make an adventure game that stars a goose, or did they start with the idea of controlling a goose or making an adventure game? What is the player experiencing that makes this game popular? Is it because there are not many or any games where you control a goose? Is it the subtle story or the simple mechanics? A lot goes into designing the elements of a game before even beginning to write lots of code or create the finished art assets. It is important these design steps are taken so the rest of the game production can be organized. Cool. So that was lesson 1, and that was a completed lesson. So now we have a quiz. The space, state, actions, rules, necessary skills, and elements of chance are known as the game's... No, mechanics. Cool. I knew that. The meaning of the game's objective. Goal of the game, storyline, interaction between game goal of the game. Okay. True or false, all games must have a storyline. No. What is one of the most important things to keep in mind when designing a game? Player experience. What is the first thing we should think about when designing a game? Game type. Yeah. Which of the following is a type of game controller? The steering wheel. Which best illustrates the objective of a game to a player? The game type, the objective of a game. So, probably the type? Oh, the storyline. Okay. I don't know. I was kind of torn between those two. What's the definition of a game platform? The physical hardware. Yes, the physical hardware it's played on. Yeah, I got 75, which is usually a fail, but I see why, though. I'm also, like I said, quite tired, So now we're going to be moving on to game design job roles. Learn about the different job roles involved in video game design. Now that we've learned the fundamental steps of video game design, let's look at some of the different design-related job functions. Creative director, which is something I would absolutely love to do. The creative director, or the lead game designer, decides on how a game looks and what it's like to play. Working with other lead roles, the creative director makes some important fundamental decisions that lay the foundations of the game's overall look and feel, such as what genre or elements would best fit the story or rules of the game. They ensure all deadlines and budget restrictions are met once the game is in development and make changes otherwise. Project management and a solid foundation in a wide range of video game development disciplines are key to becoming a successful creative director. The concept artist. The concept artist is responsible for designing, drawing, and sketching, by hand or digitally, game elements, including objects, characters, and environments. Their sketches contribute to determining the mood and even the video game's storyline. They may work with the creative director and other designers to determine the sketches needed for each level or scene in the game. A concept artist may need to conduct significant research to reference the objects or specific characteristics that need to be sketched. They may generate multiple revisions and versions of the sketches until the required specifications are met. A background in art or graphic design and knowledge of design software is helpful for this job role. Game marketer. Video game marketing targets the proper demographic by representing the game's story, look, feel, or any other design element that will increase sales. The game marketer's job includes promoting the game on social media, designing, preparing, and placing advertisements correctly to get the maximum viewership, and reaching out to influencers to this must be relatively recent. The development of this lesson to mention influencers to secure contracts to promote the game. This process can start early in the development process to ensure an accurate representation of the game's main themes and selling points. More design roles. Systems designer. Every aspect of a video game must work together within an organized structure. The systems designer is responsible for maintaining and adapting this structure to ensure that all game elements work together seamlessly throughout production. The writer. Every story needs a writer. This is no different for video games. Writers help create a game's story that will help connect with the players and create a fun, immersive experience. Project coordinator. This role is essential to all stages of the production process. Project coordinators work to support the entire team with necessary resources, whether in design, development, or asset creation. Gameplay development introduction. Once we have gone through the design process, we must make fundamental decisions to turn that creative vision into reality. These decisions will lay the foundations of our game's overall look and feel, such as what elements would be best fit for the story or the rules of the game we have in mind. However, before making these decisions, we must first look under the hood and understand the core concepts that make up a video game. It's easy to get lost in the excitement of playing a video game. If we take a moment to pause and reflect, we'll discover all the elements working in tandem to give life to the joyful spectacle we're experiencing. How did a unique blend of genres with inventive mechanics paired up with the realistic and automated behavior of the characters come to be? This lesson will discuss some essential aspects of video games, including gameplay, mechanics, AI, user experience, and interface, and customization. Take a look at the screenshot from The Witcher 3 in the workspace. What components of video game development do you see? There's more than meets the eye. Okay. What components of video game development do you see? Environment design, UI design, well, I guess I was gonna say map, but like, that's UI. We have like a day-night system. We have armor rating, levels, lighting, location, inventory, our player character and their design, stuff like that. That's what I noticed. Also the reference point for the player being able to call what they need to perform on the screen so they don't have to memorize it. Gameplay. Take a moment to think about what the term gameplay means. Does it describe the type or genre of a video game? Is it how the player interacts with the game? Or is it the rules that define how the game is played? Players have varying definitions of gameplay, but most will agree it has to do with their experience with the game. I agree, as a player. Gameplay is more than the pattern defined through a game's rules or the interaction of many game elements. It encompasses the entire experience of playing the game, including the relationship between the player and the game, the goals or difficulties the game introduces and how the player overcomes them, the plot and the player's part in it. Gameplay also includes how much a game adheres to or departs from the gameplay formula within its genre. For example, Minecraft, Call of Duty, Portal, and Superhot, which I've played all of these and they're all great, are technically first-person shooters, but each has distinct gameplay. Keeping this in mind, we can diversify gameplay into many different types, including the following. Cooperative. A co-op game allows players to work together as teammates against one or more non-player characters, NPC, opponents. Asymmetric. Asymmetric gameplay usually refers to when multiplayer games, Asymmetric gameplay refers to multiplayer games where the same game is played by two or more groups of players but with different gameplay mechanics. Most notable examples are zombie or survival games in which one team of players tries to survive the monsters controlled by the other players. Non-linear. Non-linear gameplay allows players to choose where they go or what they do next. Their journey branches out like a tree. This freeform system of progression is usually highlighted in open-world games and massively multiplayer online role-playing games, MMORPGs. That is a mouthful. Whatever you said the full title. Emergent. Games with emergent gameplay have mechanics that change according to the player's actions. It asks players to make simple decisions that collectively lead to complex situations. Any game in which the narrative of the story changes based on the player's decision is an example of emergent gameplay. First thing that comes to my mind is like Fable. Click through the slideshow to review the gameplay concepts introduced in this exercise. So we just went through that, so we don't need to do that. Mechanics. Ooh, Final Fantasy. Now let's discuss an essential element in gameplay, mechanics. We can define mechanics as how the game will work for the people who play it. This definition is different from gameplay, how the players experience the game. Specific core game mechanics make up the game's overall characteristics. We can think of mechanics as an engineering concept, whereas gameplay is more of a design concept. For example, consider the goal of a fighting game, to hit your opponent while not being hit yourself. We can deconstruct this basic gameplay idea into mechanics like punch, kick, block, throw, dodge, etc. We can further break it down into light punch versus strong punch. I define game mechanics using concepts from object-oriented programming as methods invoked by agents, designed for interaction with the game state. Miguel Sicart, PhD in Game Studies. Technically, mechanics are the rules that guide the player's actions and the game's response to them. It also describes what the player can do with the character. Let's look at some examples of fundamental game mechanics. Movement. Movement can vary drastically in different types of games. For example, 3D games will allow 6 degrees of freedom, while platformers restrict movement to only left and right. Other movement mechanics include jumping, swimming, sprinting, etc. Energy points, health, shield and armor, magic, action points, etc. Character actions, shooting, crafting, attacking, taunting, etc. Resource management. Management of resources like money, land, natural resources, etc. Even how the game handles health regeneration or player death are mechanics. Artificial intelligence, or AI. Self-driving cars, recommendation systems, voice assistants, these are all great examples of what AI can achieve, but what does it do for video games? AI is the ability of a computer system to perform tasks commonly associated with intelligent beings, such as driving cars, translating languages, folding laundry, and yes, even playing video games. AI in video games is most commonly used to control non-player NPC behavior. AI can drive NPCs to act more intelligent, as if a human player were controlling them. Having NPCs react to a player's actions can make a game feel more responsive and adaptive. AI powers an NPC's decision-making ability, so when the player blocks an NPC's path who's trying to go from point A to point B, the NPC can choose an entirely different route on the fly. Interactivity introduced by AI can result in more immersive gaming experiences. Basic AI in video games follows a simple 3-step cycle: sense, which is observe their surroundings; think, make a decision; and act, carry that decision out. Let's consider an enemy in a platformer game. To decide whether to attack the player, it gets the distance to the player's character, asks itself if it's close enough to attack the player, and if so, it attacks. Otherwise, it waits. AI in an RPG is not so different. Get all the player character's health, determine whether character is weakest, and attack that character. These are fundamental scenarios that can be programmed without AI. Implementing advanced AI in video games is shown to be beneficial. Today's games have become more innovative and realistic. For example, Red Dead Redemption 2. One of the thousand revolutionary aspects of this game is the behavior of the NPCs. Every NPC that populates the world of this game lives a virtual life, completing chores, working, and pursuing hobbies. Fear. NPC opponents in this horror first-person shooter learn from the player's playstyle. As the game progresses, the player is forced to constantly switch strategies since enemies don't repeat the same mistakes. Minecraft. Procedural generation of levels makes games replayable and eliminates the predictability of the in-game world. AI in video games enables the integration of complex behaviors without needing to manually code behaviors, saving time and cutting costs. This is something I have absolutely no idea about because as far as I've gotten in my game development journey, I have to code everything. My NPCs do exactly what I say. In Cody's adventure, we will have gotten used to how the enemies act. What happens if we can alter the enemy's sense, think, act style? Use the sliders checkbox. Use the sliders checkbox and drop downs to create different enemy behaviors and try out in the game. Enjoy. So this is just everything. This is not working though, for some reason. I'm not quite sure. They really should have bug tested before they released this. User experience or UX. User experience, UX, is a crucial aspect of any software product. In video games, UX is just as important, if not more, as any other component of the game development process. But what is UX anyway? UX promotes the user's emotional response to a product. It embraces all aspects of how a user interacts with a product, including how engaging the experience is. The goal of UX is to improve usability and ease the interaction between The goal of UX is to improve usability and ease the interaction between users and the game, which increases player satisfaction and loyalty. How do we make good UX? Designers have dedicated entire careers to trying to answer this question. We must first understand that UX is more than what's going on the screen. It's about understanding human limitations like perception, attention, and memory. Celia Hodent, director of UX at Epic Games, has created 7 usability heuristics every video game designer should follow. Number 1 is signs and feedback. Signs are information that tells the player something will or can happen, whereas feedback, visual, audio, haptic, etc., is a response to an action. Clarity. All symbols and text on the screen should be legible and perceived as intended. Form follows function. The form of an object gives information about its function. Consistency. All controls, signs, feedback, and UI should be as consistent as possible. Minimum workload. Reduce the burden on memory. Error prevention and recovery. Help players prevent or quickly recover from errors. And flexibility. Let players customize their gaming experience. Subpar graphics or stories can be tolerable for some players, but a bad UX frustrates everyone. We may uninstall our games quickly without intuitive interfaces and proper responsive interactions. Let's highlight some good UX practices we often see in video games. Color indicators are used for different scenarios where red could represent something for immediate attention and green for the player's health. Subtitles, in most text-based games, are color-coded to the character and certain words are animated to express emotion. In fighting games, we usually have combo indicators. Enemies typically have indicators next to their head when they're attacking or alerted. So we're going to go through the slideshow. In Rise of the Tomb Raider 2015, the player is still immersed in the environment as they level up their skills, so we can see Lara and the campfire. This is a mechanic here that allows you to access other mechanics while not taking you out of it, like diverting to a completely different menu. It stays in the game. Dead Space 2008. This horror action game doesn't pause as players access their inventory, leading to a more immersive game experience. So yeah, Isaac here, I believe it's Isaac. I have not played Dead Space yet. I do plan to, but it's more like a open, kind of transparent sci-fi little thing he's got going on. Probably something to do with his helmet or something, I would imagine. But it doesn't take you out of the game because you still have it framed here. So you've got Isaac here, the environment is still visible and also visible through the transparency. Fortnite. Played it like twice. Many usability heuristics are being utilized in this game, including minimum workload. For example, the ammo type for each gun and the number of resources the player has are always displayed. So yeah, you've got like it's very tiny, sorry, but you can see your weapon types here. I think this is player health. This is like your goal. This is your level up notification and your map, and your cardinal directions here. So yeah, and you're up probably. I think these are probably like gameplay updates. I can't read them, but that's what I'm gonna assume. So yeah. Metal Gear Solid, big classic, 2010. Whenever an enemy is alerted of the player's presence, the game displays an exclamation mark above the enemy and plays a warning sound. Overwatch 2016. This game actively shows the round status, points, kill feed, and healing or damage vignette on the screen. User interface, aka UI. Let's move on to something more familiar, user interface. From car dashboards to this Codecademy page, user interfaces are a standard part of everyday life. The best of which are the ones we don't even notice. A user interface is a way for humans to interact with computers and, in our case, video games. Regarding a digital product, UI encompasses all the elements that enable users to interact with the product. In comparison, UX is what the user takes away from the entire experience. UI design has a significant impact on UX, especially in video games. One common UI element in video games is the heads-up display or the HUD. The HUD displays several pieces of information relevant to the game and might include health, magic, ammunition, weapon, minimap, compass, and more. What's ultimately shown on the HUD heavily depends on the game, and some developers may even choose to disguise it as part of the game or hide it entirely for the sake of realism. The HUD is an example of the minimum workload usability heuristic because it reduces memory load on the player. In other examples, other examples of UI in games include the main menu. This is a starting point of any great experience. A video game main menu must be polished and immersive because it's where players will get the first impression. First thing that comes to mind for me is Persona 5. I hear all the Persona games are great about that, but Persona 5 is the only one I've played so far, and I will never forget that. It's actually inspired a game that I'm working on right now. I'm trying to model my UI as close to like Persona as possible. So yeah, big influencer in the UI aspect. Tutorial. If our game features never before seen mechanics or has complicated rules, we must take the time to design a hands-on tutorial. Sorry if you guys can hear those cicadas, they're like super loud because it's like midsummer. But map. A detailed yet easy to understand atlas of the game world is essential, especially when the world we design is large. We want players to explore every corner of the world, but they quickly get turned off if they get lost for hours. I'm trying to think of a game that did that for me, because I had like an emotional memory come up, but I don't remember. But yeah, that's definitely very important. There is no correct way to design a UI in a video game. UI is one of the most challenging aspects of game development because of its subjective nature. We must spend time designing effective UI and UX in our video games to provide users with a comfortable experience while in our game. This is Apex Legends, which I actually was a tester for about 3 months, and I hate this game. Oh my goodness, it was something else. So flexibility. Video games nowadays are more immersive than ever before. A big reason behind this is customization. Customization gives players the freedom of choice on how they want to play. Recall the flexibility Recall the flexibility. My goodness, that is a tongue twister. Recall the flexibility usability heuristic from the UX exercise. Allowing players to customize their gaming experience. Providing flexibility can be as simple as adding the following options. Game settings. Allow players to change settings like resolution, language, sound levels, etc. We could let them edit UI colors or change HUD transparency. Gameplay tweaks. Allow players to affect gameplay with character or weapon customization, adding the ability to change playstyles at any time, and even tweaking the way AI behaves by changing difficulty levels. Quality of life. Adding quality of life features such as weapon loadouts, fast travel, Skippable cutscenes and fast restarts also goes a long way in improving the gameplay experience. Accessibility enables players with disabilities to feel most comfortable by changing the UI and game controls. Think color correction for colorblind people. However, letting gamers play the way they want is a double-edged sword, absolutely. Providing too many options can overwhelm players, especially new gamers. Adding customization that affects gameplay can break balancing, especially in multiplayer games. Always ensure the added customization doesn't significantly alter the intended game experience or take away from the story or emotion we're trying to convey. The best customization options are the ones that barely affect the game's design. It's even better when integrated into the game's world or story. Fast travel, which allows players to travel further distances in less time, can easily be inserted into the game's narrative, think like Oblivion or Skyrim. Remember that customization is not necessary, but pay close attention to player feedback. Players often overlook flexibility in video games unless it's missing. Take a look at a screenshot of the settings menu from Forza Horizon 5. This racing game includes a plethora of options to adjust the difficulty of drivatars, cars controlled by the AI. Every option, such as manual shifting, that makes the game harder to play increases the bonus currency awarded at the end of each race. Notice other configurable options the game offers, such as accessibility, HUD, and language selection. Head on over to the next exercise to finish the lesson. Okay, so yeah, we've got difficulty, accessibility, HUD, gameplay, controls, advanced controls, your audio, video, and your graphics, and your language select. So you can change the drivatar difficulty, their assist preset, braking, steering, traction control, shifting, driving line, damage, and tire wear. Wow, that's so cool. Okay, so that's like really in depth. Review. Congrats, you made it to the end of this lesson. Now we're familiar with some essential aspects that make up gameplay. As a review, gameplay is a set of mechanics, and it's ultimately what the player takes away from the gaming experience. Game mechanics are the rules that govern and guide a player's actions and the game's response to them. AI in games makes them more interactive and immersive. AI can be programmed to do everything from pathfinding to NPC behaviors. Advanced use of AI is the future of gaming. Its limitless capabilities remain unexplored, but we know it has the power to make games smarter and realistic while saving time and money. UX encompasses all aspects of the user's interaction with a video game, while UI comprises all the elements that enable us to interact with it. Following usability heuristics and guidelines such as diegesis theory, sorry, I've never heard this before, diegesis theory help us design a good UX and UI. A good UX and UI allow players to be more engaged in the gameplay for more extended periods. Allowing players to customize their gaming experience is not a necessity, but a welcome addition to video games. Understanding these concepts will surely help us on our journey to developing our first video game. Recall the screenshot from The Witcher 3 at the introduction of this lesson. We stated that there's more to this screenshot than meets the eye. Regarding components of video game development, now that we're familiar with the essential aspects of video games, let's analyze the image from the perspective of a video game developer. Gameplay. It isn't easy to extract the gameplay type from one single screenshot. Witcher 3 is an open world, which I have played, by the way. It's an amazing game. CD Projekt Red, they know what they're doing. Witcher 3 is an open world action role-playing game, ARPG, so we can expect non-linear gameplay. The presence of a mini-map further confirms an enormous game world. Mechanics. We quickly notice some basic fighting mechanics displayed on the HUD, like attacks, dodging, and casting spells, like I highlighted right here. As a 3D game, it is also safe to assume freedom of movement in 6 degrees. Swimming is not out of the question either, thanks to the presence of the water. Energy points like health, mana, and even armor are shown on the HUD. We can also expect this game to have resource management and crafting due to the presence of potions and sword types. AI. We see a few enemies called drowners, which are emerging from the bushes and charging toward the player. This suggests that the game most likely has different behavioral trees for different kinds of enemies and NPCs. UI and UX. There's a lot of UI and UX showcased in the screenshot. The HUD shows all the crucial elements the player should be concerned about, such as health, equipped weapons and potions, weather and time, location, and even basic controls to lessen the burden on the player's memory. There's even an indication that one of the player's armor pieces is about to break. The nearest enemy has its name and health shown above its head to indicate that the player attacks will target this entity. All of these things improve the gaming experience for the player. And lastly, flexibility. Though not shown in this screenshot, it is expected from a famed developer such as CD Projekt Red to include a diverse range of settings and customizability for the player. We can expect that they'll allow players to fast travel, hide the tutorial controls from the HUD, and enable accessibility options like colorblind mode and change the language of the game. Next! Cool, so we are done with that section. Here's the quiz. Let's see if I can do this one. Which of the following sentences best describes the term gameplay? It's the experience. Yes, okay. Which of the following is not an example of a gameplay mechanic? Action points, money, instant response, sprinting, minimap. Oh, not a minimap, because that's UI. Which of the following is not a benefit of a good UX? Increase player satisfaction. Nope. Decrease gameplay. Nope. Helps players easily recover. This one. I said no, but that's because I was just going through my options. True or false? AI in video games is most commonly used to control NPC behavior. Commonly? Yeah, okay. So, which of the following is not an example of a UI in video games? That would be... Oh, enemy attack indicator. Why? Not quite. Having an interface menu to change. Oh, I thought that, but enemy attack indicator. I would think... I'm gonna have to see the explanation on that one. All of the following statements about adding the flexibility heuristic in video games are true, except flexibility can break game balance. It's often ignored by players. It's optional. Gives players freedom of choice, and it makes games easier. All of the following statements about adding flexibility are true, except... Yeah. Flexibility makes games easier. Doesn't necessarily make games easier to play. Okay. I gotta know. I gotta know why that one was wrong. Which of the following is not an example of UI? Enemy attack indicator. An interface menu for changing in-game settings is considered a UI. Yeah, I get that. But on the other hand, an enemy attack indicator is part of a mechanic. Okay, I guess so. Alright. If you want to be technical about it, sure. Alright, next lesson. Gameplay development job roles. Did we not just go through this? No. Oh, we went through game design. Gameplay development job roles. Learn about the different job roles involved in gameplay development. Now that we know some critical aspects of gameplay development, let's look at some job roles in this field. Gameplay designer. Gameplay designers are one of the core aspects of game development. They work closely with the creative developer to design the game's mechanics. Focusing on the gameplay, they constantly tweak the mechanics to ensure it is well balanced. Gameplay designers also make sure the game's specifications are technically achievable. If a gameplay idea or mechanic is too challenging to achieve in the allotted time, they work with developers to make adjustments or rewrite the specifications. Artificial intelligence programmer. Programmers focused on artificial intelligence bring life to a game's non-playable characters. They code the brains of the game so that the NPCs make decisions or behave in a realistic yet appropriate way to the game's settings. They further ensure all hostile NPCs provide a varying degree of challenge to the player. The AI programmer demands a high level of experience in programming and strong math, analytical, problem-solving skills. That is so true. UI UX designer. This is something I'm also interested in. Companies often seek out designers dedicated just for user interface and user experience. UX designers ensure players don't have a bad experience playing a game. They focus on delivering clear and practical feedback to a player's actions, making the game fun and easy to use. UI designers, on the other hand, focus on the interfaces the players are greeted with. They make sure all the interactive parts of the game, menu, HUD, commands, are easy to understand. Together, these designers assure that the information a player needs to play a game flows well and is communicated clearly. More gameplay development roles. Build engineers. The build engineers do quality assurance. They need to ensure an up-to-date build of the game is released whenever it's updated and improved. Community managers. The community managers focus on the players. They are actively involved with fans on social media, attend events, write newsletters, hold live streams, and address any constructive feedback. That sounds really fun. And then this is one I've actually done, which is game testers. A game needs to be tested before and even after it's released. Game testers write detailed reports of bugs, glitches, typos, and anything out of place they find. Super, super fun job, by the way. Introduction to assets. Picture your all-time favorite video game. What aspects of the game help to make it a favorite? Is it the relatable or exciting characters, the captivating graphics in each scene, or the musical soundtrack? These video game features are assets that These video game features are assets that help make the game more enjoyable and memorable. An asset in game development is an art component that contributes to the game's look, feel, and sound. Examples of assets include the characters, visual environment and scenes, sound effects, and soundtracks. In this lesson, we will cover what assets are and how they've transformed over the years, how asset objects are conceptualized and modeled for game integration, how character assets are created, how environment or scene level objects are created, how sound effects are created, and the different ways in which they're used in video games, how musical compositions or the soundtrack for a game is created and used. It's time to learn and play. And for our examples here, we have the classic Pac-Man 1980. Wow. Mortal Kombat 2019. The Sims 4. Back to Pac-Man. Alright. History of game assets. Lara Croft. The classic blocky boob meme queen. History of game assets. Assets are a crucial component in video games in that they contribute to the look and feel of the game. Assets help keep the player enticed and engaged in the game's storyline and gameplay. Some examples of game assets include characters, level environments, interactable and non-interactable objects. I almost said raptor. Tired and focusing on dinosaurs, sound effects, and music. Over the last 30 years, we can see that significant technological advances have contributed to more realistic characters, environments, and engaging soundtracks. As assets have improved in quality and detail, we can easily distinguish games from each other from their unique characters, colors, and recognizable sounds. Imagine the characters or sounds from Pac-Man or Super Mario. Game assets have transformed from 2D objects into 3D, as an increasing amount of time and budget are devoted to creating them. Quality assets not only keep players immersed in the game, but can also be a crucial advertising component when it comes to time to market to video. My goodness, I'm so sorry. Quality assets not only keep players immersed in the game, but also can be a crucial advertising component when it comes time to market the video game. Next, let's cover the base process of an asset creation when using... I'm sorry guys, I really need to go to bed. Next, let's cover the base process of an asset creation used when developing many types of assets. View the flip card of Lara Croft. This character asset is from the video game Tomb Raider of 1996. Click the card to see the newer and improved version of her from 2018. Wow. So she went from simple polygons and like blocky structures to a woman with rendered hair and guns and an actual waistline and a face. And her boobs are round, which is the biggest change. Asset conceptualizing and modeling. To make a video game come to life, the characters and objects designs must be modeled and fine-tuned. Bringing a video game asset to a state where it can incorporate it into a game... Bringing a video game asset to a state where we can incorporate it into the game involves some or all of these steps. Conceptualizing. This first phase in the asset creation process produces detailed descriptions of what the object or character should look like, including illustrations, models, and sketches. These quick, rough drawings may involve many rounds of rework or revisions. Sculpting. This stage transforms the concept materials into actual 3D models. Modeling the objects can be done using various 3D software tools like Blender or Spine, and involves creating models that have either low or high quality details. Texturing. This stage uses visual effects created from 2D images wrapped around the modeled asset to provide realism and detail to the object. I don't know why I can't scroll down here. So we're just going to keep reading from here. UV mapping. Why can I not scroll down? I feel like this is really badly done. UV mapping, which I hate. This is literally so awful. We did this in school when I was learning like the basics of 3D, and it's freaking awful. But UV mapping is the process that involves wrapping the created texture onto the newly modeled 3D object. Baking. And this is the process of transposing 3D geometric characteristics onto another model, and is common when converting a high-detailed model into a low-detailed model. And lighting. Adding lighting helps with depth perception based on the location or state of the character or object within the environment. This process can involve adding shadows, to the modeled object, or directed lights to create a lighted effect over the scene. The below examples show a low and high poly object and the baked result with texture, UV mapping and baking applied. Though several revisions may occur throughout all the steps of this creation process, the steps for our modeling assets are generally consistent whether we are modeling background or foreground objects or characters. I cannot see it. Either way, I cannot see it. Sorry, we do not have the example in this module. Creating character assets. Creating characters in video games are the driving force behind the gameplay and help direct the plot and storyline. Such a critical component of the game requires equally important art assets to bring the characters to life, which we can accomplish through added visual elements that help the character fit into the game's overall theme. As an example of this could be using assets to support the time frame that a game is set in. For instance, a medieval-style game will likely have characters with appropriate medieval-style clothing and weapons. After the characters have been initially thought out and designed by the artist, we can sketch a silhouette of the character. The silhouette sketch is an integral part of the character conception process as it communicates many features about the character, such as physical features. Details like skin, hair, and high-level details like beauty marks can help the character look more natural. And subtle features, such as the character's build, pose, or facial expressions, can help the player determine which character to select in the game or communicate this character's intentions regarding the plot or storyline. If you have ever played a game in where your character had to make a real-time decision of whether another character was a friend or enemy, assets likely impacted your decision. Features like clothing, pose, and facial expressions of the character can be used to influence the player's decisions. Creating environment assets. Game levels are the space or environment in which the player... I'm not going to bother with these because it's not working. The scroll is not working anyway. Game levels are the space or environment in which the player performs actions to achieve a goal. Environment assets are all details that appear in the level that help to advance the storyline and further immerse the player in the game. These assets involve both the foreground and background components of the scene. Foreground objects may be objects that move or interact with the player, while background objects are intended mainly to enhance the look and feel of the environment. An environment asset is first sketched out by researching and collecting references for all the objects and components featured in the scene. Environment design can differ significantly from a mobile device compared to a console. The smaller screen size on mobile devices requires different sizes and even fewer components in the environment scene. Limited hardware capabilities on a mobile device compared to a console may also affect the level of detail given to specific assets. So for example, this background is pretty simple, all things considered. The foreground as well. We've got one background, one foreground, a couple of foreground interactable elements, and like a very simple HUD. The above screenshot is of the fast-paced, side-scrolling action game Jetpack Joyride 2. This screenshot contains layers of assets. The foreground assets include the big boss mechatronic on the right, and the scared lab workers running on the floor. The background assets do a great job of creating depth by layering different pieces of the stage, from the floor and ceiling to the multiple rock formations further in the background. Creating an entire scene involves multiple assets that work together seamlessly. We could go back to Cody's adventure if it worked, so we're gonna skip that part. Creating sound effect assets. Whether you're playing imagine you're playing a video game where the main character must walk around through an old abandoned warehouse. There is silence all around you except for the warehouse floors that creak with each step the character takes. There is a slight sound of dripping water in the background, and the wind whistles and howls through the broken windows. It loaded! It's loading! Sorry. Oh, I thought it was gonna actually work. My bad. Sorry for setting expectations. These sound effects help create a heightened sense of suspenseful state for you as the player. All of a sudden, there's a loud bang from upstairs. You might be startled or frightened now, or maybe excited as to what the possibility is and what's on its way towards you. Sound effects are a crucial component of video games, adding another layer of engagement for the player and aiming to invoke certain moods within the player depending on the scene. I am such a huge advocate for sound design. I think it is one of, if not the most important thing in the game. After you get the visual tonality figured out, absolutely focus on your sound. It is so critical. Sound effects can help convey several points of the game. They provide information to the player about the plot or environment, and in our game example, sound effects help the player determine that the environment is abandoned. Provide feedback on the player's actions. If the goal as you explore the abandoned house is to collect resources along the way, a chime sound effect could play as you pick up items. These sounds provide positive feedback to you as the player to indicate that you have successfully collected the item. They provide emotional effect. As the loud bang occurs, the player is immediately alerted to the possibility that they may not be alone in the house, after all, possibly invoking a frightened or excited response to continue the gameplay. The following are several types of sound effects in a game. Narration. This can be dialogues between characters or narrated text to give additional information to the player. For example, you try to open a locked door in the house and the character goes, "It's locked." Ambient sounds. These are sounds within the background noise that help to set up a scene, like howling wind and dripping water heard in the background of our example. Sound effects. These sounds are typically used to capture the player's attention, such as loud bangs, crashes, or explosions. Foley sound effects. These are sound effects that match actions in the gameplay, like a player bumping into a table and then a thump sound plays, or the player must break open a window to enter the house and the sound effect of glass breaking plays after that. Creating musical composition assets. Think of a game you played where the level was so intense that your heart rate increased as you gripped the controller tighter. Dark Souls. The accompanying music within the scene likely had much to do with this elicited response. Thematic and incidental music is a key piece to video games and helps invoke a wide range of emotions from the player as they navigate through the storyline. Music can also help establish the timeline for the storyline or foreshadow an event that's about to happen. Adaptive music or interactive music is a standard in video games. The music responds to specific events in a game through a tune, volume, and rhythm change. One challenge with creating musical pieces for video games is that each player will compete with certain scenes, tasks, or levels at different speeds. They'll complete them at different speeds. Creating complementing blocks of music can help address this problem. A well-developed composition will seamlessly loop some of these music blocks for players who require a bit more time to complete a level so that there is no awkward silence during that section of gameplay. There are several types of music blocks for a video game that can all vary in length and connect at various points. Intro. This introduces and sets the mood for the game, level, or scene. I'm thinking like Breath of the Wild, where Link walks out of the cave and it like pans and the orchestra comes up, right? Loop. These blocks repeat a section of the music until an event happens, such as the character dying, an object that is found, or any other gameplay change occurs. So I'm thinking like survival horror, right? For example, like Clock Tower, because the chase music sticks with me. It is so scary. It sticks with me to this day. It was Clock Tower 3. It goes like doot da 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 doot da 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 ah. Like, it's so freaky and heart rate inducing. And then when you die, I don't know what the sound effect is, but usually like it'll kind of like fade out and it'll go like or something like that, which is super cool. Stinger. This indicates a momentous event that happens in a game and typically only lasts a few seconds. For example, if the character is climbing up a cliff and loses their grip, a clip of intense music may start here, increasing the intensity of the gameplay. There is also a location-specific stinger where a short music clip plays when the character enters a new location to the game. So let's think of Legend of Zelda again, where Link gets something from a chest and it goes da-na-na-na, or Mario when he powers up. Brr, brr, brr. And then for the specific stingers and location, I'm thinking like Dark Souls or other Souls-born games where you come into a new area and it goes like, right? Or like that whoa kind of. I can't make that noise with my mouth, but like whenever you open a door and like you unlock a new area. And then a tag. This indicates the end of the scene or level and helps the player know that they've completed the level. I don't know any games I've played that do that. I'm thinking more like the older, more simple games. Or Pac-Man. Pac-Man's a good one. I don't remember the sound, but like I know Pac-Man would kind of play something. The sound clips and tracks for a game should all complement and flow with each other to provide a cohesive soundtrack. Sorry, not soundtracked. Okay, and we already went through this. Review. Congratulations, Elden Ring! I love Elden Ring. Congratulations, you completed the game development assets lesson. In this lesson, you have learned the importance of creating game assets, the history and progression of game assets, the process for creating and modeling assets, the visual asset creation process for characters and environments, the musical asset creation process for sound effects and soundtrack compositions, how these assets are used in games and influence the player's gameplay or emotional response. Now that we know how assets are utilized, let's manipulate the following games to modify assets within the game. Continuing further, we can learn about the specific job roles that are responsible for designing and creating these assets. Game asset job roles. Learn about the various job roles responsible for creating and integrating game development assets. Now that we've learned what assets are in game development, their importance, and how they're used within a video game, let's cover some essential job roles responsible for designing and implementing these vital game components. The 3D artist. The 3D artist is responsible for the sculpting process to transform sketches from concept artists into 3D models. A background in art and understanding how to best combine colors, textures, and lightings are valuable skills for this role. Other helpful tools include knowledge of image editing and 3D modeling software like Blender or Spine, and some familiarity with the game engines. Environment artist. The environment artist is responsible for creating the game's backgrounds, scenes, and environments. They create storyboards or prototypes to mock up the game levels, and they must understand the game's characteristics, such as hardware limitations to prevent overly detailed environments that may slow gameplay speed. Knowledge of 3D modeling software to sculpt backgrounds that work well with objects and characters is an integral part of this role. Audio engineers. They work with the sound designer to assess what sounds are needed and where within the game they should go. They use SFX libraries for sound material, or may even create custom sounds from scratch. Knowledge of audio and software equipment for modifying and creating sound effects and mixing soundtracks is helpful for this role. More asset roles. The art director. They're responsible for conceptualization phases and supervising the final production stages. They work with the 2D and 3D artists, concept artists, and more roles from the creative staff to oversee the creation of these essential visual components of the game. The character artist. A specific type of 3D artist is the character artist, who primarily designs the animated characters in the game. This artist works with the art director to bring anatomy, physical behaviors, and facial expressions to the character sketches. A background in art and knowledge of modeling software like 3ds Max or Maya is beneficial. Composer. The video game composer creates the musical scores for the game. The composer not only writes the music but also arranges and orchestrates it before it can be integrated into the game. The composer should be very familiar with the gameplay in its early stages to determine the sounds and mood of the music to create. Introduction. Congrats on making this far in your game development journey. So far we've learned about game design, gameplay mechanics, and the assets used in video games. In this lesson, we will learn about something all those areas of game development have in common: the tools. Without tools, modeling characters and coding mechanics would be such a tedious task. Simple projects would take months or even years to prototype, and only a handful of people would have the expertise to do so. Like a mechanic needs a screwdriver or a painter needs an easel, there are tools for every role in game development. Sound designers have audio production software to create and edit audio assets. Programmers have different languages and compilers to write logic. Animators have modeling software to bring 2D or 3D characters to life. Game development has software that provides every tool needed to make a game. While the video game industry boom in the past few decades led to the many tools available today, the tools are partly responsible for the boom. Tools make every aspect of video game development more productive while reducing production time and costs. These tools give life to the scale of games never before imagined, and give indie developers the power to create worlds, tell immersive stories, and connect players around the globe. Take a look at the screenshot from the workspace of Red Dead Redemption 2. What tools do you think the developers used to create this masterpiece of a game? Obviously 3D software, shaders, probably ray tracing, knowing it's Rockstar, either Blender or Maya, most likely Maya, that's the 3D standard. Programming languages. Programmers play a significant role in game development. They turn designers' visions into code and create video games by implementing features like physics, AI, networking, and even creating tools to accompany the rest of the development team. Let's discuss some of the popular programming languages in game development. C++. C++ is the most popular programming language used for game development. Its unmatched performance and proximity to hardware make it the standard for consoles and PC. The language's low-level components may make it a complex language to learn, but it might be worth the time and effort for developers looking for the most flexibility and control over their games. Moreover, C++'s object-oriented design helps us create maintainable and reusable code. Even though C++'s latest revisions have modernized the language, developers may prefer other languages when coding time is more important than performance. C#. C# is a simple and modern object-oriented language designed by Microsoft. While it's a perfect language for building games on Windows and Xbox, Microsoft has developed tools and frameworks to make their language cross-platform. It can also be used as a back-end language to communicate with servers. Java. Java is a Sorry guys, I've been talking I think for like an hour now. Java is a cross-platform, object-oriented language that runs on a virtual machine, making games easier to scale and distribute. Its collection of open-source material and support for multi-threading and socket programming make it popular for building indie, mobile, and multiplayer games. HTML and JavaScript. HTML is the core technology behind games run on web browsers and mobile platforms like iOS and Android. It packages HTML, CSS, and JavaScript together to create an interactive online game. Since games built with HTML5 are deployed in a web browser, they can be played virtually by anyone. Lua. Lua is a high-level, lightweight, and cross-platform language that runs on virtual machines. Because game development often incorporates multiple languages to capture the designer's vision fully, game developers find Lua convenient due to its highly embeddable nature. This makes it easy to integrate into other applications. Roblox is an excellent example of integrating Lua to create games using the game engine, which we will cover in the next exercise. I cannot talk anymore, my goodness. What is a game engine? Imagine if we wanted to create a simple pinball game where players could select from various balls, including a metal ball, a baseball, a basketball, or etc. We want the balls to have realistic textures and physics properties as well. To accomplish this, we need to model and texture all the balls, implement realistic physics, design levels, and finally, program the logic. What if we had a tool that handled the majority, if not all, these tasks for us? Game engines, or game frameworks, are game development environments that simplify, optimize, and speed up game development cycles. They come packaged with a diverse set of tools that provide the needed core functionality essential to developing a game, including rendering, generating images from 2D or 3D models; physics, pre-configured settings and configuration to simulate real-world behavior and collision detection; lighting, handle various lighting effects including diffusion, scattering, ray tracing; AI, create behaviors for all game elements; sound, create sound effects; and asset store, download pre-built and sometimes free game assets. Game engines lay down the foundation for developers to build upon. Utilizing these tools can drastically cut production time and costs. Instead of worrying about coding physics or managing memory, developers can devote their time, energy, and money to focus on the mechanics or story of their games. Some engines even provide the ability to port games from one platform to another. Game engines. As with programming languages, we have plenty of choices when choosing a game engine for our development. Each game engine has its strengths and weaknesses. The choice ultimately depends on the game we want to build. As we explore more games and the game engines used to power them, we may begin to recognize and discover that each game engine has its own quote-unquote look and feel. Unity. One of the most popular game engines is Unity. It supports 2D or 3D games on 25 plus platforms, as well as AR and VR games. It uses C#, it's easy to use and has a simple interface, features an asset store with tons of free assets, and according to 2021 Gaming Report by Unity, it was used to make 90% of all Samsung Gear and 53% of Oculus Rift VR games. It's the engine of choice by 61% of game developers. It's responsible for many mobile games, including Pokemon Go and Temple Run. Unreal Engine. Developed by Epic Games, Fortnite is a powerhouse behind many popular games. Offers virtually every tool for developers to capture their creative vision. It features high-end graphics with its state-of-the-art rendering and lighting engines. It uses C++ by default. Can support other languages such as Python. Alternative blueprint visual scripting system to add logic, behavior, and interactivity without touching a line of code. Features a marketplace full of free assets. Due to its powerful abilities and tools, however, it may not be the best engine for small team or solo game development. Unreal Engine is better suited for 3D games and 2D games. Godot. Godot has gained popularity due to its simplicity and free commercial license. 2D and 3D capabilities, uses GDScript by default, which is a Python-like scripting language, but it has support for C++, C#, and other languages. Features a unique node and scene organization to design games with ease. Other game engines worth mentioning include CryEngine, which was used to make Cry of Fear; Game Maker Studio 2, which I believe was used to make Undertale; and Pygame. Don't know anything that was made with Pygame off the top of my head. Many of these game engines are open source, meaning the community constantly improves them. Even though most of them are free to get started, some require us to purchase a license to distribute the game commercially. Epic Games, for example, takes a 5% royalty fee after a game earns $1 million in gross revenue. Before starting development, research the features, tools, and pricing and licensing options. Game engines for the web. Creating stunning, high-quality interactive games on the web has never been easier. Thanks to recent advances, web games are more than just simple card games or 2D games. 3D shooters, RPGs, and simulations are now possible. HTML5. HTML5 is simply jargon for a collection of modern web technologies. Besides HTML, CSS, and JavaScript, HTML5 comes out of the box with several APIs and technologies like WebGL and WebSockets to take web game development to the next level. Moreover, HTML5 games have the obvious advantage of being cross-platform, given their ability to work on any modern device. Fortunately, there are an overwhelming number of game engines for HTML5. Let's go over some of the most popular ones. Phaser. Phaser is a fast, free, and open-source 2D HTML5 game engine that uses WebGL and Canvas rendering to develop games for web browsers across desktop and mobile. Third-party tools and plugins enable developers to easily add additional functionality, such as compiling their games as native iOS, Android, and desktop applications. GDevelop. GDevelop is a free, full-featured open-source HTML5 game engine for building 2D games. Its main appeal are its visual programming and one-click cross-platform distribution. It allows JavaScript functionality for those who want to extend the engine's capabilities. With a single click, the game engine can export to standalone game. No, I read that right. With a single click, the game engine can export to standalone games on many platforms, including Windows, Linux, and mobile. Construct 3. Construct 3 is an HTML5 game engine capable of building 2D and 3D games. Like GDevelop, it offers visual programming with the addition of JavaScript and the ability to distribute games to many platforms efficiently. While it provides many features like a game engine of its caliber, I read that right, it's important to note that Construct 3 is not entirely free. Honorable mentions. It is not easy to narrow down the best HTML5 game engines. Ultimately, it comes down to the features the game demands, but it would be remiss of us not to mention the following game engines due to their unique abilities and impact on the web game developers community. Impact.js, free top-quality 2D and 2.5D game engine. PlayCanvas, 3D HTML5 game engine with cloud-based tools. Pixie.js, fast 2D rendering engine, can easily create rich, interactive animations, graphics, and games used by many game engines including Phaser, GDevelop, and Impact.js. 3.js, most popular JavaScript framework for creating and animating 3D graphics in the browser. Asset tools. Even though game engines allow the development of all genres of games, sometimes they are not flexible enough to capture our entire artistic vision. For this, we must highlight the best tools meant for creating assets. Everybody knows Blender. Blender is a free open-source 3D creation software. It can do anything in the 3D pipeline, including modeling, rigging, animation, simulation, and rendering. We can use it to create visual effects, 3D models, 3D and VR applications, and even animated films. It also features a Python API for custom scripts, allowing itself to be integrated into other tools. Quick little side note, I watched a video the other day where the developer of Choo Choo Charles talked about how he, instead of UV texturing in Unreal, I think he used, he just did it in Blender, and he just imported his assets, I think. So he literally just did everything in Blender and then imported it and then tweaked it in Unreal. Character Creator. If we do not model our characters, we can use Character Creator by Reillusion. With Character Creator, we can easily customize and add highly realistic character assets to our games. It allows us to tweak attributes like age, weight, skin, hair, teeth, etc. The market is filled with community-made assets like outfits, animations, morphs, light presets, and more. From there, we can easily integrate characters into our game engine. Pro Tools. Regarding sound design and editing, nothing comes close to Pro Tools. Pro Tools can make any audio asset if we want to create sound effects, ambient sounds, Foley, background music, or dialogue. Distributing and publishing. One of the best feelings in the world is having others try out the game we devoted so much time, money, and effort to. In today's digital world, there is no longer a need to burn games onto physical CDs, package the case, and distribute it to thousands of stores worldwide. However, I will always miss physical games. Always. The game manuals in the box, used to read it on the way home when Mom bought me a game and we'd go home. I'd read the entire manual. I even kept the Sly Cooper Thievius Raccoonus manual as a book, just because it was so cool. I loved it. Digital games are selling more than ever, and game marketplaces have never been more accepting of indie games. It's the perfect time to get our games out there. PC. Itch.io. Itch.io is an indie game marketplace. The best thing about Itch.io is that it doesn't have an application fee, content review, or waiting periods to publish games, nor is there a DRM requirement or exclusivity clause. Steam. Steam is the most popular video game storefront on PC. It provides users with features such as the ability to upload game saves, automatic game updates, user-created content support, social networking, and more. However, publishing on a popular platform like Steam and integrating its features into our games doesn't come without additional policies. I do believe that if you want to make a Steam page for your game, it's like $100 or something like that. There are several other digital video game storefronts available for PC games such as Epic Game Store, Humble, and GOG. Console. Since indie games like Minecraft rose in popularity, console manufacturers like Sony, Microsoft, and Nintendo can no longer ignore indie developers. Each of these companies now has an indie developer program. Sony's PlayStation Partners, Microsoft's ID at Xbox, Nintendo's Developer Portal. Mobile. If we want to share a game made for Android or iOS, we can turn to Google Play or Apple's App Store respectively. Web. Web games have the advantage of working on any modern device with a browser, given that we optimize the game for various screen sizes and input types. Distributing on the web gives us the powerful ability of a hyperlink. We can use links to distribute our games on social media and generate hype. If we have profits in mind, we can consider monetizing with ads or using a marketplace like itch.io. Whatever platform you choose, reviewing each marketplace's policies and fees before submitting a game is essential. Review. Good job on making it to the end of this lesson. You should now be aware of the plethora of tools and resources available to turn your gaming vision into reality. We've discussed the importance of choosing the correct programming language and the right tool for the game or task. Embrace the freedom of choice and do research before committing. Remember, one game engine or platform isn't necessarily better than another. The popularity of a game engine also means very little. The most important thing in video game development is the passion for building video games, creating breathtaking worlds, inventing unique characters and immersive stories, coming up with the next big gameplay mechanic, and finally sharing it with the rest of the world. In the first exercise, we looked at a screenshot of Red Dead Redemption 2, where the main character was on their horse, looking over a detailed landscape. Dutch. This screenshot is from the same game but contains a very different complex world. An intricately designed town with multiple stores to explore, bustling with computer-generated characters, each with their own story. The potential experiences of this game affords each player the potential experiences this game affords each player are a product of the many teams of people and the tools they use to create such vast opportunities. I love my horsey and my horsey love me. Game development tools, job roles. Learn about the job roles that work with the various game development tools. We are now familiar with some common tools and programming languages used in game development. Let's discuss some important job roles that can use or even modify these tools to complete their tasks. Level designer. Level designers extensively use tools such as game engines to craft dynamic and immersive levels, challenges, and missions. They spend time researching and understanding the specifications defined by gameplay designers and then implement the details, actions, events, objects, and environments into the game. Since their job is to keep the player focused and moving through the game without confusion, they often have to imagine themselves in the player's shoes and map out all the possibilities. This involves them constantly considering the logic, sequences of actions, and the conditions that must be met for certain events to trigger. Tools engineer. Tools engineers make their fellow game developers' lives easier by providing them with the best tools for the job. They modify or create their tools to support the game development, development of the game. This requires them to work with programmers, artists, and designers to determine what tools to build, explain their usage, and observe their effectiveness. The custom tools developed by the engineers handle many tasks to provide efficient workflow while saving time. These tasks might include the conversion of assets like 3D models and textures into formats suitable for the game, bringing assets from game engines directly into 3D applications like Blender or graphic editors like Photoshop, writing scripts to automatically build new versions of the game as it's being worked on. The work of a tools engineer can vary from day to day as the needs of a game developer change. Engine programmer. Sometimes, existing game engines may not be adequate to capture the complete vision of the development team. To overcome these limitations, engine programmers must build a base engine from which the game runs. The base engine is usually a customized and repurposed version of one of the more popular game engines, and they add new features and rewrite the existing functionality to make the game engine efficient as possible. More roles. Almost every role in game development uses a tool to accomplish its task. We would be remiss not to mention the following roles that play a vital game in effectively using the tools to increase productivity. Artists. Animators, character or environment artists, and modelers use tools to represent their visions in 2D and 3D worlds. Localization specialists. Translating in-game text, voice scripts, manuals, and other supplementary documents into several different languages are some of the tasks of a localization specialist. Publishers. Game developers deal with publishers for financial support and avoiding the hassle of distributing games. Publishers ensure the game is being developed, as agreed, to budget, and on schedule. Next steps. Congratulations on completing the Introduction to Game Development course. Here are some next steps if you're interested in more game development content. So they have introductory programming courses, which will teach you, the Code Foundations path provides an overview of the main applications of programming, computer science, web development, and data science. It also teaches essential concepts that you'll find in every programming language. Variables, data types, operators, functions, control flow lists, loops, survey of the computer science industry, survey of web development industry, and survey of the data science industry. You can learn C++, learn C#, Java, and Python, which goes into all those game engines we talked about earlier, so those would be useful things for you guys to learn. Game development for the web teaches you all the JavaScript, phaser stuff, UI and UX they have a course for. So Codecademy pretty much has stuff for everything. This one was free, so I was not stealing from anyone by making this content. This was more so just to give you guys a run through with me as we both learn together through this course. But congratulations, even though you didn't do anything with me, you just finished Introduction to Game Development, and we've completed game development tools already. So that was nearly 2 hours of the Introduction to Game Development on Codecademy. I hope you guys learned something. I sure did. A lot of this was basic stuff that I already knew, but I did learn a few things, like certain game engines I didn't know existed, certain programming languages I didn't know existed, and other small details. So that's the entire point of me doing these series, so we can all learn, little small things we've never learned before or didn't know before. So thank you guys so much for sticking it out with me. I hope you learned something, and I hope you took one step closer to becoming a game developer and, igniting your love for video games the same way I love them. So this was Smoke with Smoke Arts and Moonwraith Studios. Thank you guys for watching. I'll see you in the next video. Bye, everybody.